Okay, Mr. Baumer here, and we're continuing in the second half of Chapter 9. All right, Chapter 9 is all about quadratics. Again, the second half for us, this unit of study for us, is about solving quadratic equations, okay? And we've already learned a couple ways. We've already learned 3 ways, or been working on 3 ways that we'll continue learning about, and today we're going to learn a 4th method. So, while you're writing down the objective here, student will be able to solve quadratic equations by, and here's the technique we're going to use, taking the square root of each side of the equation. Right? Again, student will be able to solve quadratic equations by taking the square root of each side of the equation. All right? Now, you can put your pencil down for a second after you've written that down. If you need to hit pause, go ahead and do so you can finish writing that down. But I want to show you 3 things here. These are the 3 methods we've already been working on: graphing, factoring, and the quadratic formula. All right, now let's remind ourselves, how do we solve a quadratic equation by factoring? All right, well, if we had something like 0 equals x squared minus 1, right? How would we solve that equation by graphing? Well, you'll recall, hopefully, that what you do is you switch that 0 to a y to make it a quadratic function, and then you graph this. Now, I happen to know that when you graph this, it looks like this. The vertex is at 0, -1, and then if I were to make a table of values to surround that, I would find that the zeros are actually at 1 and -1. Right? So the solutions to this equation are actually the zeros. They're 1 and -1. Now, factoring. We could take the exact same equation here and factor it. How would we solve that by factoring? Well, the first thing we want to make sure is that we set it equal to 0. And then you want to factor the quadratic expression, which in this case would be x plus 1 and x minus 1. And then we would write our mini equations, which is based on the 0 product rule, which allows us to solve these equations. I know that either that is 0 or this is 0. So I can write what I've been referring to as our mini equations. I could say either x plus 1 equals 0 or x minus 1 equals 0. Now, I can solve those. I get x equals -1 or x equals 1. Same answers we got over here. Now, quadratic formula. Well, first of all, you're not going to be able to use the quadratic formula if you don't memorize it. So you need to memorize this. And then this, what do I have written here? Well, that comes back to the same date at the beginning of the year I keep mentioning, August 21st, all right? That when you're going to evaluate an expression that has a bunch of variables in it, I think it's a good idea to first rewrite the expression, replacing every variable with a parentheses, because then you just need to plug values in. So, if we're looking at this thing right here, what is the value of A? Well, A is 1. What's B? B is 0. What's C? C is -1. Therefore, you could just plug these in. Well, what goes here? 0, 0, 1, -1, and 1. And if you evaluated that, you would get these 2 answers again. All right, so those 3 methods, just a quick review of the 3 methods we've already been using to solve a quadratic equation. And today we're going to learn a 4th, called taking the square roots. Now, again, here's a reminder of the 3 methods we've used. All right, and today we're going to be learning how to solve by taking the square root. And it's important that we realize when this works and when it doesn't. All right, so let's look at here. This primarily works in 2 situations. All right, one of them is when the quadratic does not have a linear term, meaning there's no x term. So if you look right here, x squared minus 9 equals 0. There's no x term. There's a quadratic term, there's a constant, but there's no linear term. When you have an equation that looks like that, this method is going to work really well. All right, the other method, or the other time, the other situation that it's going to work in, is when the quadratic is written with a quantity squared. So you look here, x minus 3, that quantity squared equals 9. All right, so when you have it written like this method will also work. All right, and I've given us some steps here that we'll refer to as we work on some of these problems. So let's look at this. Let's look at this top problem here. Solve. 2x squared minus 32 equals 0. Well, the first thing I'd want to realize is, hey, wait a minute, there's no x term. All right, there's no linear term. So this meets one of those situations right here. It meets this one in which this technique works really well. So I think I want to use this technique. Now let's look at step 1 down here. It says set up the equation so that the expression, the thing being squared, is equal to the constant. All right, so we need to get the thing being squared alone. All right, we need to get this thing right here. Make sure you notice what I'm doing here. We need to get this alone, not the 2. All right, not the 2. I only need to get x squared alone. All right, so how am I going to do that? Well, I'm going to have to move two things. I'm going to have to move this and this. Now, which one should I move first? All right, well, we're solving, so we're really working PEMDAS backwards, so to speak. So I'm going to move that negative 32 first, so it becomes 32 over here. Then I'm going to divide by 2 to undo the multiplication by 2. Now, if you look down here at our steps, step 1 says set up the equation so that the thing being squared equals a constant, meaning just a number. So we've accomplished that on this problem. Now, step 2 says take the square root of both sides, and it says remember plus or minus. So we need to talk about that a little. So how do I take the square root of both sides? Now, I just put this in there, because the real issue here is how do I get x alone? Well, what undoes squaring? Square rooting undoes squaring. So I also need to do it to this side, because whatever I do to one side of the equation, I have to do to the other in order to keep my equal sign. But the key is you have to put a plus or a minus symbol in there, because there are really two numbers that when I square them, I get 16. All right, so what do we get on the left? Well, what's the square root of x squared? It's x. On the right, I get plus or minus. Now, what's the square root of 16? It's 4. So I really have two answers. X equals 4. Or x equals negative 4. Those are the two values that would make this original equation true. And that's really what solutions are, the values that make an equation true. Now, let's look at this next one. Again, same steps apply. We need to get the thing that's being squared alone. So how do I get x squared alone? Well, the only thing I have to move in this case is the negative 10 needs to move to the other side. So if I do that by adding 10 to both sides, what is negative 10 plus 10? Well, it's 0. All right, so now I've accomplished step 1. Now I need to undo the squaring on x by taking the square root of both sides and putting a plus or minus in front of it. Now, what is the square root of x squared? It's x. What is the square root of 0? Well, it may look like my answers are plus or minus 0, but is there any difference between positive 0 and negative 0? No. So the only answer is 0. Now, if we want to tie this back to the graphing that we did earlier as a technique for solving it, how many zeros would this one, would the related function have? It would have 2 zeros, at positive 4 and negative 4. How many zeros would the related function to this have when we graphed it? It would only have 1, right? Meaning the vertex would be on the x-axis. Now, this third one. All right, I'm going to solve it here, but if you want to hit pause and try it yourself, that might be a good idea. All right, so if you want to hit pause and then come back and you'll see my solution here, that might be a good idea. But what I'm going to do is recognize that I need to get x squared alone. Now, how am I going to do that? I'm going to have to move the negative 24 and the 4 to the other side. So I get 4x squared equals, adding 24 over here, makes 25. Now, I need to get x squared alone, so I need to divide both sides by 4. So now I have x squared equals 25 fourths. Now I need to undo the squaring. So I'm going to take the square root of both sides, remembering to put the plus or minus there. It's very important. A lot of students forget that. So x equals, now, some of you may look at that and go, oh, boy, I don't know what the heck that is. But if you'll take a second to remember this property from earlier in the year, the square root of a over b can be thought of as the square root of a over the square root of b. What's the square root of 25? Well, the square root of 25 is 5. And what's the square root of 4? It's 2. So our answer is really plus or minus 5 halves, which means 5 halves, which is 2.5, is one of our answers, and negative 2.5 is our other answer. All right, another problem here. We got a lot of problems here to go through. How do I get this thing? How do I get, the first thing I need to realize is that, hey, wait a minute, there is no x term. There's no linear term, so I might be able to use this taking a square root method, but I need to get that alone. So, in order to get that alone, I'm going to need to move this to the other side and this to the other side. So, what do I get when I do that? Well, the first thing I get is I get 100x squared equals 49. And now I need to divide by 100. So I end up getting x squared equals 49 over 100. Hopefully you'll recognize that 49 and 100 are both perfect squares, so I shouldn't be intimidated there by the fraction. Now I need to take the square root of both sides to undo the squaring. X equals plus or minus, so x equals plus or minus, what's the square root of 49? 7. What's the square root of 100? 10. So my answers are x equals plus or minus 7/10, which means positive 7/10, which is 0.7, is an answer, and negative 7/10 is also an answer. All right, now, you can try this one if you want on your own, but I'm going to go to the next page here and look at this one, because this one's a little different, right? This one really falls into that second situation we need to look for, when the quadratic is written with a quantity squared. All right, when the quadratic is written with a quantity squared, our same exact steps still apply. Now what I need to do is I need to get x plus 2 squared alone. All right, I need to get that whole thing alone. Well, how do I get that alone? Well, I just have to move the positive 1 to the other side. So if I do that, I'm going to get x plus 2, that quantity squared, equals 9. Now, I could FOIL this out, and then it would make a quadratic that would have a linear term. All right, and I could pick out a, b, and c. I could use the quadratic formula. I could graph it. I could see if it's factorable. But you guys are so used to trying to get rid of parentheses that I know a lot of you think immediately to FOIL that. But here there's a benefit to not FOILing it, because what do I really wish wasn't there? I really wish this 2 wasn't here. All right, how do I undo squaring something? Well, that is, by definition, what square rooting does. It undoes squaring. So I can take the square root of both sides. Now, what do I get on the left? Well, what's the square root of chunk squared? What's the square root of a quantity squared? Again, you have to understand the fact that square rooting and squaring undo each other. So what I get here is x plus 2. What do I get on the other side? I get plus or minus 3. Now that gives me 2 equations to write. Either x plus 2 equals 3, or x plus 2 equals negative 3. And then I just solve those, which are pretty easy to solve. They're both linear equations. Here, subtract 2, x equals 1. Or here, subtract 2, x equals negative 5. All right? Now, in this one, I'm just going to start you off with the fact that you need to get this thing alone, all right? You need to get the quantity 3x plus 1 squared alone. So I want you to try that problem on your own, and I'm going to check when I look at your notes that you have at least attempted this problem, all right? So get 3x plus 1 squared alone, and then take the square root of both sides. All right, so work on that, and we will see you in class where we'll keep working on solving quadratic equations. Looking forward to it.